Okay, Madam minta maaf sebab delay sikit sebab don't know why hari ni dan hari sebelumnya pun ada problem. Before this, Madam test macam tak ada masalah. Okay, sepatutnya kita ada 68 today. Sekarang, full. Okay, congratulations. So, Madam nak sambung sikit hari ni. Let's have a look at good notes. Notes awak tu. Again, kalau ada soalan nak tanya, you guys boleh interrupt, boleh raise your hand, no problem. Okay, so we continue. Last time we look at the proton number, nucleon number. That one, Madam tak pergi detail sangat lah. Okay, so Madam ada introduce to you guys mass spectrometer, iaitu alat yang digunakan untuk cari berat sesuatu atom ataupun molekul. Okay, so ada dua cara untuk kita calculate average atomic mass. The first one adalah kita gunakan formula kimiki. Okay, actually formula ni lagi senang. Okay, so you can use formula kimiki untuk calculate average atomic mass. Q adalah your relative abundance. Fatihah. Tak apa. Okay, Q adalah relative abundance. M pula adalah mass untuk sesuatu isotop. Okay, so another way to calculate average atomic mass is like this. Di mana Madam convert each of the relative abundance ataupun relative intensity tu, Madam convert dia jadi dalam bentuk decimal. Okay, so this one agak panjang sikit lah. Kalau guna kimiki, dia lebih mudah. Okay, so better guna kimiki. Okay, next kita tengok this one. So if you guys want to find out average atomic mass, you guys boleh guna kimiki. Next, soalan boleh tanya lagi, how to find out relative atomic mass. So kalau nak cari relative atomic mass, kena bahagi dengan average tadi, bahagi dengan 1/12 times mass of carbon 12. So that one. Okay, I left you with this question. Okay, boleh tengok example 4. Okay, nitrogen. Okay, dia bagi proton number. Z is the proton number. Okay, jangan risau kalau awak tak ingat proton number. Dalam exam, dia akan bagi. Okay, dia akan bagi kepada awak proton number untuk sesuatu elemen. So, tak perlu hafal lah. Cuma Madam nak minta awak tolong print out list of the relative atomic mass. Ada kan Madam bagi dekat Telegram tu, yang tu kena print out sebab dalam exam nanti yang itulah yang akan diberi kepada awak. Okay, so kita boleh tahulah yang mana satu yang diberi dalam exam, yang mana satu tak ada nanti. Okay, so for this one, dia dah bagi average atomic mass 14.0067 AMO. Okay, dia bagi isotopic mass. Isotopic mass means that mass for the isotope lah. For nitrogen 14, nitrogen 15 dia dah bagi. Okay, so dia nak calculate percentage abundance. Okay, let's say lah untuk dua isotop ni, total percentage abundance is 100. So kita buat assumption kat sini. Let percentage abundance of nitrogen 4 equals to X. Okay, so maksudnya kat sini, the next one, abundance for nitrogen 15, you just minus 100 minus X. Okay, jangan guna Y. Sebab nanti susah bila kita ada tu unknown. Ini bukannya macam matematik kita nak solve X, Y. We just want X. Okay, next step. Tengok kat situ. Madam guna formula average atomic mass iaitu Kimiki. Okay. After that, okay, substitute all the value. Okay, substitute all the value. So you should get for X 99.64%. So that is our X. So untuk abundance for nitrogen 15, you just minus 100 minus X. Since X is equal to 99.64, so balance is 0.36%. So this is the abundance for nitrogen 15. Okay. Any question here?
Madam,
Yeah.
about the 100 minus 99.64, can I just straight away write 0.36%?
Boleh. No problem.
Okay, thank you, madam.
Okay, welcome. Okay. Boleh je, no problem. As long as you don't forget to include percent. Here, percent ni, if you tak ada percent, markah nanti tak dapat. Okay, any other question for this one? If not, I proceed. Okay. Okay, so madam proceed lagi. This one. Ramai orang cakap, madam tak reti buat lah yang ni. Okay. Example before this, the relative abundance given in form of percentage. Now, the relative abundance is given in form of what we call this? Pecahan pula, ratio. Okay. So, what we can do here, actually, you just put over 1. Okay, because 1.555 divided by 1 equals to 1.555. So, kita letak per 1. So, means that here, relative abundance for X21 is 1.555, while relative abundance for X22 is 1. So, we just proceed macam biasa, use the formula. Okay, substitute. Okay, substitute cuma tengok kat sini. Okay, for X21, the relative abundance is 1.555. For X22, the relative abundance is 1. So, you just tambah nanti kat bawah ni. So, you should get 21.35 AMU. Okay, so Q here, always remember, dia adalah relative abundance ataupun relative intensity. So, the value can be in form of percentage ataupun decimal. Okay, ataupun nombor biasa. Okay, so for dekat bawah ni, you just tambah 1.555 plus 1. So, you dapatlah 21.35 AMU. Cuma bila you bundar, okay, you akan dapat 21.4 lah, as is in the question. Okay, so for this one, ada apa-apa nak tanya?
Madam. So, jawapan dia, decimal place dia X
Dia sebenarnya dia akan bagi tahu, tapi nak selamat biasanya 2 decimal place lah.
Okay.
Cuma masa kita buat calculation, normally we use 4 decimal place. Okay, but the final answer is in 2 decimal place. Okay, so okay, kita ambil masa sikit Why don't you guys try question in worksheet 2, question number 3. Okay. Sekejap Cuba buat worksheet 2, question number 3 sekejap. Cuba buat sekejap Question number 3. Later I will ask someone to present screen Dan okay. Sama je macam yang kita buat tadi. Okay, Li Yishen, are you here today?
Yes, madam.
Okay, can you show me your answer? You boleh present screen sekejap. Sekejap, where's my... Yishen boleh share screen tak? Tak boleh? Yishen boleh?
Where are teacher?
Sorry?
Uh,
Sorry,
sign in first off.
Sorry? No, it's okay lah. Tak apa. Anyone would like to share his or her answer? Anyone? Okay. No one? No one willing to... Ya? Siapa ni? Siapa bercakap?
Send jawapan kat Telegram.
Apa?
Send jawapan kat Telegram.
Boleh juga send jawapan kat Telegram. Okay. Dah ke? Dah send ke?
Belum sekejap.
Okay. Okay, let's have a look. This one. Okay, she gave me the... Apa ni ya? Oh, this is the mass. Okay. This is the relative atomic mass. Okay, for each of the isotope. Okay, then she show me the ratio is actually 3.127 over 1. Okay. Tak ada masalah. Cuma sekejap madam kena sekejap. Where's the... nampak pula tu. Good notes. Sorry lah. Sekejap. Okay. Jalan kerja ada problem sikit because you doesn't show me the formula. Tiba-tiba kan, ni apa dia ni? Tiba-tiba ada sama dengan. Okay. So before this step, what you need to do is tulis average atomic mass sama dengan Ki. Okay. After that, barulah this step, show this step. Okay. Next, dah tekan calculator, you get 35.45 AMU. Okay. Betul tak jawapan kawan kita ni? Ni siapa hantar tadi? Lina ke siapa tadi? Who sent me this one? Siapa hantar Tak apa, kita belajar sama-sama. Siapa ni? Ya. Siapa? Syakila. Kila.
Bukan.
Siapa hantar?
Dari orang lain yang hantar.
Ni siapa ni ya? Aziz. Okey Aziz, tak ada masalah. Cuma soalan tanya calculate AR. AR tu bukannya average atomic mass. AR adalah relative atomic mass. So maksudnya kat sini tak lengkap lah. Okay, so you have to Untuk cari AR is relative atomic mass. So masukkan average atomic mass tadi, AMO, divide by 1/12 times 12 AMO. So actually this step, kita just nak cancel out 12 and also AMU. So jawapan masih samalah, iaitu 35.45. Okay, ada masalah? Boleh faham ke this one?
Boleh, madam.
Boleh so take note kalau average atomic mass yang kimiki, kalau relative atomic mass sama macam step average atomic mass, however just tambah one more step. Okay, the cancel out step ni. Okay, good. Okay, good.
Dekat bahagian yang dekat soalan tu kan, 3.127 tu, saya buat cara lain.
Awak buat cara macam mana?
Yang 3.127 tu, saya jadikan pecahan.
Okay.
3.127
Sekejap.
per 1000.
3.127
Bukan.
per 1000.
3.127 per 1000.
Okay. Dapat tak?
Sekejap, saya send kat madam lah.
Okay. Tengok hari ni tiba-tiba ada cara lain kan. So actually doesn't matter which one as long as you get the answer correct lah. Siapa tadi? Hanis Hanis Syazwani. You dari tutorial mana?
MS
17. Dah send ke? Okay. By the way, untuk kelas hari Selasa, kita punya kelas pukul 8. Tapi madam akan buat kelas pukul 9 . So pukul 8 tu madam akan bagi video dekat you guys. So you guys nanti study the video first. Then the second hour we will discuss question together. Where? Okay, jadikan 1000. 4127 ni apa? Total Total, okay. Rasanya, okay. Madam dah faham. Okay. Betul, tak ada masalah. First time madam jumpa, tapi I don't think there's a problem with this calculation. Okay, then you tukar dia jadi pecah. Bukan apa? You tukar dia jadi decimal, which is good. Okay, you use kimiki. Cuma yang ni jangan malas sangat, Anis. Aja satu-satu. Average atomic mass. Oh, this one. Okay. Then you show me. Yang bawah pun betul lah. Okay, so basically tak ada masalah. Cara ni pun betul. Cuma dia panjang sikit lah. Okay. So, it's up to you. Nak guna yang apa? Calculation macam mana tak ada masalah. As long as you get the final answer. Okay. Good. Ada soalan lain? Tak ada. Okay. Madam baru tahu rupanya kelas kita ni dah lambat. Orang lain dah habis chapter 1. Okay, tak apa. Kita go slow-slow lah. So, Then next we have a look at the next subtopic, which is mole concept. Yang ni lah nightmare semua orang. Okay, ramai orang tak suka mole-mole ni. Don't worry. Kita akan tengok balik benda ni secara ringkas. Okay. Before that, let's recap what you have learned before. So, basically, before I introduce you to mole concept, let's say kita ambil contoh kasut. Okay, kasut kita panggil dua kasut tu, kasut belah kiri dan belah kanan, kita akan panggil dia as a pair of shoes. Okay, kalau 12 telur, 12 eggs, kita akan panggil dia sebagai a dozen of egg. So unit tu macam contoh a pair, pair mewakili 2. Dozen mewakili 12. So mole ni in chemistry dia mewakili this number. 20200000. Okay, sebanyak 23 times. Okay, so 1 mole of shoes, for example, 1 mole of shoes, maksudnya bilangan kasut awak adalah sebanyak 6.02 exponent 23. Okay, so basically mole ni is a unit that we use to calculate atoms and molecule. Okay, so this number is known as Avogadro constant ataupun Avogadro number. Kenapa Avogadro? Sebab dia yang jumpa benda ni. Okay, so let's have a look at more example. For example here, I have 1 mole of sulfur. So 1 mole tu mewakili 6.02 exponent 23 sulfur atom. And the mass for 1 mole of sulfur corresponds to 32 gram. So that is why mass for one atom, for example sulfur atom is gram per mole. So maksudnya mass for sulfur is 32 gram per mole. Maksudnya ini adalah berat untuk 1 mole, bukannya 1 atom. Jenuhlah kita nak timbang 1 atom. So basically kita tak timbang 1 atom, tapi kita akan timbang based on 1 mole. That's why molar mass of anything is gram per mole. Okay, another example, potassium chloride. Okay, so 1 mole of potassium chloride contains 6.02 exponent 23 molecule. Sebab ini adalah potassium chloride wujud dalam keadaan molekul. And the mass for 1 mole of potassium chloride is 29.4 gram. Okay, dari mana kita dapat ni? Basically, this is the mass when we add mass of potassium plus mass of chlorine. Okay, so that's how we got 29.4 gram. So basically, if I ask you, what is 1 mole for an element? Okay, so your answer is this one. So nombor ni tolong hafal. Okay, kalau tak hafal pun tak apa, memang dia akan bagi, tapi membazir masa. Better you hafal this number because we are going to use this a lot. Okay, 1 mole of molecule. So molecule apa? Okay, let's say 1 mole of chlorine molecule. So 1 mole tell us your chlorine molecule has 6.02 exponent 23 molecule. So itu simple lagi. Let's have a look Okay. Let's say I have chlorine atom. Okay. So 1 mole corresponds to 6.02 exponent 23. Okay, what if question asks you how many molecules for 1 mole of Cl molecule? So kalau 1 mole, terus convert the 1 mole into the Avogadro constant. Okay. Tapi, now, soalan tanya, how many atoms in 1 mole of molecule? So kat sini you kena berhati-hati. Molecule is the combination of 2 atom. So for chlorine, chlorine is element in group 17. Okay. Remember, kalau group 17, dia akan wujud dalam keadaan gas. So, gas yang terhasil adalah, in this case, Cl2. So, means that here, in 1 molecule of chlorine, there are 2 chlorine atom. So, what you need to do is, take Avogadro constant just now, kita kena darab dengan 2. Why? Sebab 1 mole of molecule, dalam 1 mole tu ada 2 chlorine atom. So we have to times by 2. So the answer is this one lah. Okay. Next, kita ada ammonia. Okay. If the question asks you how many molecules in 1 mole of ammonia, so tak ada masalah. Terus jawab Avogadro constant. However, if the question asks you how many atoms in 1 mole of ammonia, so yang ni awak kena hati-hati. Dalam ammonia ada berapa atom? Dalam ammonia ada berapa atom? Agak-agak. Ada 4 atom kan?
Ada 4.
Allah, Medon dah tulis kat sini kan. Okay. So you have 1 nitrogen atom and 3 hydrogen atoms, so total 4. Okay, so Avogadro times by 4. Okay, you get 2.408 exponent 24. Boleh tekan kalkulator sendiri. Next. Sekejap air tak ada. Okay, dia tanya, how many nitrogen atoms in 1 mole of ammonia? Dalam 1 mole ammonia, ada 1 nitrogen atom. So, no need to do anything lah. So, the answer is Avogadro constant. Okay, next. Dia tanya, how many hydrogen atom? So, dalam ammonia tadi, ada 3 hydrogen atoms. So, your Avogadro times by 3. Very simple. So, the answer is 1.806 exponent 24 atoms. Okay, that is for ammonia molecule. Next, kita tengok compound. Okay, apa beza molekul dengan compound? Molekul form through covalent bond. Sekejap kita recap. Okay, so apa beza molekul dengan compound? So this is molecule. So molekul ni terhasil daripada covalent bonding. Covalent bonding kita akan jumpa masa chapter 4 nanti. So, sodium chloride is a compound. Kenapa compound? Because dia terhasil daripada ionic bonding, iaitu Na plus and Cl minus. Okay, soalan tanya, what is berapa berapa sodium chloride compound yang berada dalam 1 mole of sodium chloride. So macam biasalah 6.02 exponent 23. Okay, soalan tanya, how many sodium ion in 1 mole of sodium chloride? Okay, yang ni kita tahu, yang ni awak kena buat equation sikit. So take your sodium chloride, larutkan dia dalam air. Sodium chloride ni akan pecah jadi ions. So Na plus and Cl minus. So take a look at the equation. Okay, the equation is balanced already. So tak perlu buat apalah. So maksudnya 1 mole of sodium chloride dia akan menghasilkan 1 mole sodium ion. So kalau kat sini Avogadro constant, dekat sini pun nanti Avogadro constant lah. Okay, the same goes to chloride ion. Okay, sampai situ ada soalan nak tanya? No? Okay, clear?
Yes.
Okay, good. Sekejap madam. Bukan exhausted apa? Tekak kering. By the way, before that, you guys dah vaksin belum ni ya? Belum. Janganlah sedih. Dapatlah tu nanti
Kalau yang tadi tu, compound dia, contoh macam ada ion yang charge, contoh macam MgCl, Mg kan 2 plus kan?
MgCl ya? Okay, good. Magnesium chloride. Okay. Allah. Good. Magnesium chloride. Okay, formula for magnesium chloride is MgCl2. Okay, why Cl2? Because Mg is in group 2, so the charge is Mg2 plus. Okay, while chlorine group 17, charge dia -1. So this is the ion for magnesium chloride. Tetapi you guys kena balance. Dekat sini you guys ada 2 chlorine. So here you have to put 2 chloride ion. Barulah elemen tu balance. Okay. So kalau soalan tanya, how many chloride ion dalam 1 mole of magnesium chloride? This one you guys kena darab dengan 2. Yang ni. Faham ke? Siapa yang bertanya tadi? So, maksudnya lepas ni, no matter what compound they give you, you kena ceraikan dia jadi ion first. Okay, make it into ion, balance the equation. Baru kita tahu dia nak darab 2 ke, nak darab 3 ke, and so on. Okay, next, we go to the molar mass. Okay, yang ni pun awak dah pernah tengok. So, molar mass is the mass for 1 mole of atom or 1 mole of molecule or ion or formula unit of a substance. So macam madam cakap tadi lah, berat mass for 1 mole of sulfur equals to 26. Ya ke? Tengok balik. Kat mana tadi? Sorry, 32. Okay. So, okay, mari kita tengok macam mana nak kira. For example, let's have a look at example 2. 1 mole of chlorine pula, carbon. Okay, kita tahu 1 mole bersamaan dengan Avogadro constant. So 1 mole of carbon corresponds to 12 gram. Okay, therefore molar mass for carbon is 12 gram per mole. So unit tu jangan pula letak AMU sebab sekarang adalah berat for 1 mole. Okay, use gram per mole. Okay, lithium. 1 mole of lithium, the mass is 6.9 gram. Therefore, molar mass for lithium corresponds to 6.9 gram per mole. Tak perlu hafal, jangan risau. Kita akan bagi untuk awak. Dalam exam pun nanti dia bagi. Don't worry. Okay. Oh, this one ada typo sikit. Bukan lithium. Oxygen. So, same concept lah. 1 mole of oxygen, berat dia adalah 32 gram. Therefore, molar mass for kalau oxygen molecule, the formula is O2. So the mass for 1 oxygen is 16. So 16 times 2, that's what you get 32 gram. So molar mass for oxygen, okay, is 32 gram per mole. Ini simple. Okay, let's say you are given the compound, for example, water. So, nak cari molar mass of water, you just tambah molar mass of hydrogen times molar mass of oxygen. Jangan lupa darab. For example, H ni ada 2. So, 2 times 1. Why? Because molar mass of hydrogen 1. Okay, molar mass of oxygen is 16. So, tambah, dapatlah 18 gram per mole. That is the molar mass for water lah. This one Madam pergi laju sikit sebab you guys dah pernah belajar before this. Next is molar mass of, bukan water, but sugar. Okay, molar mass for sugar. So as we can see over here, there's a 6 carbon. So 6 times 12. Okay, ada 12 hydrogen. So 12 times 1. And we have 6 oxygen. So 6 times 16. So dapatlah 180 gram per mole. Okay, this one tak perlu tulis. This one, no need to tulis. No need to write it down. Bazir masa. Okay, terus pergi pada step yang darab ni. Okay, next. Throughout the course, you guys akan jumpa formula for hydrate compound. Okay, what is meant by hydrate compound? Maksudnya dalam compound awak tu ada air. Macam mana kita nak tahu ada air atau tidak? Dekat formula tu nanti, here for example, dia ada titik. Dot H2O. So means that your compound contains water. And nak hilangkan air tu senang je, kita akan gunakan teknik evaporation. So, kita akan jumpa this kind of compound later. So, to find out molar mass for this compound, molar mass of copper, okay, again, tolong bila cari molar mass nanti, tolong jangan cari guna Google. Tolong jangan guna Google. Tolong gunakan table yang madam bagi dekat awak. Kalau awak tak nak print, awak salin. Kalau rajin lah. Okay. So, gunakan table tu sebab nanti when we do the calculation, let's say your calculation a bit off. Nanti tak dapat markah. Sebab contoh dekat internet molar mass of hydrogen is 1.01. Tapi dekat dalam dalam table tu yang madam bagi tu, the mass for hydrogen is 1. So nanti calculation awak nanti takut lari. So that's why for molar mass jangan guna Google, jangan guna internet. No. Tolong refer to the table lah. Okay, so for this one, we have 1 copper. So mass for copper is 33.6 gram per mole. Plus, we have 1 sulfur. Sulfur 32.1 gram. Plus, oksigen ada 4. So 4 times 16. Okay, dot ni awak jangan darab pula. Awak tambah je macam biasa. Okay. Plus 5 water. Okay. Water, kalau madam, sebab madam dah hafal dah. Water, the molar mass is 18. Okay. Tekan calculator. You should get 249.7 gram per mole. So basically this is the molar mass for the compound. Okay, sampai sini ada soalan? Any question here? Tak ada. Okay. Tak ada. Okay, next. Madam ada bagi formula kat bawah ni. You guys can refer to this formula because later we are going to use this a lot. Okay, let's go to example 8. Okay, calculate moles, number of moles and number of atoms. Number of mole and number of molecules. Okay, gunakan highlighter. Dia nak suruh cari moles, molecules. Okay, in 1 gram of CO2. Okay, then dia nak lagi calculate number of atoms for carbon and oxygen. Okay, so cari dulu satu-satu. Dia bagi awak mass, dia nak mole. Okay, to answer chemistry problem, tolong macam mana jangan macam nak jawab yang bawah. Tolong start dengan apa yang ditanya awak dulu. For example, the first thing the question asks is to calculate mole. So kita ada mass. So to find out number of mole, kita tahu formula dia adalah mass over molar mass. Boleh refer pada apa? The formula just now. Okay, mass given is 11. Molar mass for CO2 is 44. Sebab madam dah hafal molar mass for carbon dioxide. So you should get 0.25 mole. Okay, nampak tak cara madam tulis? First is formula. Gantian, substitution. Last one is final answer. Dalam chemistry, always follow this thing. Formula, substitution, answer. Okay, settle the first question. Next, question asks you to find out molecule. Number of molecule. Okay, tengok balik formula. To find out molecule, okay, we are going to use the third formula. Okay, so the third formula is mole sama dengan number of particles time Avogadro kan. So particles, particles ni can be atoms ataupun ions ataupun molecule. So soalan tadi dia nak molecule. So maksudnya mole yang kita cari tadi darab dengan Avogadro. So use the third formula. Okay, yang ni yang pertama. Okay, yang kedua madam buat kat bawah ni lah. Okay, we want to find out number of molecule. So tadi number of mole darab dengan Avogadro. So this is the formula. Gantian dia adalah 0.25 times 6.02 exponent 23. So you should get 1.51 exponent 23. Unit dia, because the question asks you for the molecule, so the unit is molecule. Okay, so that's how we solve the problem lah. Okay, last question. Calculate number of atoms for carbon and oxygen. So you kena tahu formula for CO2 is CO2. Okay. So means that 1 mole of CO2 contains 1 atom carbon, 2 oxygen atom. So this one you boleh buat sendiri ya. If you don't understand, you can ask me. Example 9. This one pun you can do on your own. Okay, sampai situ ada soalan nak tanya? Madam laju sangat ke? Okay ya. Okay, Madam nak sambung sikit lagi ya. Sorry ya. Sebab kita pun start lambat sebab masalah teknikal tadi. Mana? Okay. Kita tengok formula. Chemistry tak boleh lari daripada formula. Okay. There's 3 different types of formula. Empirical, molecular, structural formula. So, apa beza tiga-tiga ni? Cuba kita tengok. Hydrogen peroxide. Molecular formula for hydrogen peroxide is H2O2. Okay, molecular formula adalah formula that shows exact number of atoms. So, maksudnya dalam hydrogen peroxide ada 2 hydrogen atom, ada 2 oxygen atom. To draw empirical formula, we simplify the formula. So yang ni kita bahagi dengan 2. So the empirical formula, the simplest formula for hydrogen peroxide is HO. Okay, structural formula pula adalah formula yang tunjuk, formula that shows how atom connected to each other. So this is structural formula for nama apa? Hydrogen peroxide tadi. Okay, so this is the definition. Tolong hafal. Actually, Madam ada letak simbol sebenarnya. If you jumpa simbol-simbol buku ni, means that you kena hafal. Okay, first definition is empirical formula. Macam tadilah, Madam cakap, is a formula that shows simplest ratio of atoms of different elements present in a molecule. For example, sugar. Okay, glucose ni tadi. Okay, so this is not simplest ratio. Okay, simplest ratio for sugar, kita semua number ni kita bahagi dengan 6. So the empirical formula for sugar is CH2O. So next, molecular formula. Molecular formula is a formula that shows actual number of atoms of different element. Okay, for example, for this one, you have 4 carbon and we have 10 hydrogen. So this is molecular formula. Jangan pula pergi bahagi 2. So jadi C2H5. Jangan pula tulis macam ni ya. This is not molecular formula. Okay, molecular formula, you have to show how many atoms present in a compound or in a molecule. Okay, Apa kaitan empirical dengan molecular formula? So, antara empirical dengan molecular formula, dia ada kaitan, and we are going to use this formula a lot. Okay, nanti madam tunjuk. Okay, awak boleh go on lagi ke ni? Madam nak tunjuk satu example. Then we finish the class. Boleh ke? Boleh. Okay. 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 The relationship between empirical and molecular formula can be expressed by using this formula. Okay. N sama dengan molar mass divide by mass of empirical formula. So what is N? N adalah ratio antara molecular mass dengan mass for empirical formula. For example, molecular formula for water is H2O. Empirical pun H2O. Kenapa? Sebab kita memang tak boleh simplify formula for water. So means that the N is 1. Okay, peroxide tadi, we can simplify this one by divide by 2. So that's why N dia ni 2. Ni kita bahagi 2, ni kita bahagi 2. Okay, benzene, we can simplify the formula by divide the atom with 6. So dapatlah CH. So N dia adalah 6. Next, ethene. Okay, we also can simplify this formula by divide with 2. So empirical formula dia adalah CH2. So N dia 2. So that's how we got the number of N. Okay, so now we are going to determine empirical formula. So there's 3 ways to determine the empirical formula. But for today, Madam will show the first one is by using masses of compound. So maksudnya kat sini kita akan gunakan mass of compound to find out empirical formula. So kita tengok satu-satu. 18.3 gram sample of hydrated compound. Ingat tak tadi Madam ada sebut pasal hydrated compound, means that your compound tu contain water. Okay, kita tak tahu lagi compound apa. Okay, baca lagi. Contain 4 gram of calcium, 7.1 gram of chlorine and 7.2 gram of water. Means that you have calcium, tapi tak tahu lagi berapa kalsium kan? Letak X. Next, kita ada chlorine. Tak tahu lagi berapa bilangan atom chlorine. Letak Y. Water. Tak tahu lagi water ada berapa. Letak Z. So basically, we are going to find out X, Y and Z. Okay. So next, we fill in the table. Mass of calcium dia dah bagi 4 gram, chlorine 7.1 gram, this one water 7.2 gram. Okay, dalam exam, Madam diberitahu di semester examnya multiple choice question. So maybe kalau sebelum ni memang awak wajib lukis table. But maybe lah Madam rasa you akan disuruh untuk isi tempat kosong. Madam tak sure lagi macam mana dia akan tanya dekat exam. Okay, this is the first time. First semester kita multiple choice question je. Tak ada, biasanya kita memang subjektif. Okay, so Madam rasa maybe the question will give you the table. Maybe dia ada kosongkan certain part and you have to calculate. Okay, so berbalik pada table kita tadi. After you fill in the mass, find out number of mole. So 4.0 mass over molar mass. For this table tak perlulah letak the formula, no need. So the molar mass for calcium is 40.1. You should get 0.0998. For chlorine, the molar mass is 35.5. You guys can press your calculator sambil-sambil tu. Mana tahu madam ada silap kira kan. This one you should get 0.4. Okay, if the table you dah letak mole siap-siap kat sini, so during the calculation you don't have to put unit. Okay, so daripada 3 yang kita dapat ni, find out the lowest number of mole. Untuk kes ni, the lowest number of mole adalah kalsium. So take 0.0998 divide by 0.099. Ayo. So you will get 1. So yang ni pun sama. You bahagi dengan 0.0998. So you kena bahagi dengan semua ni dengan 0.0998. Okay, you should get for chlorine 2, water you should get 4. Okay, actually there should be another table kat sini, iaitu empirical formula. Maybe dia terkat masa madam tukar jadi PDF. So okay, the final answer is calcium. Ada satu je S. Okay. So jangan pula tulis Ca1 . Cl ada 2. Dot. Our Z is 4. 4H2O. Okay, so this is our answer. Okay. Tapi kan you get okay ke ni? Boleh ke? Madam rasakan alang-alang ni, madam sambung sikit lah, kita habiskan semua empirical formula, boleh? Lagipun next class kita jumpa Selasa kan, lambat. So bolehlah you guys revise sikit-sikit. Okay, we will look at second method is by using percentage composition of a compound. Okay, that was the first step. Yang ni yang kedua. Okay, yang kedua, the question can give you mass in form of percentage. Okay, so for example, a sample of hydrocarbon. Hydrocarbon means that your compound hanya ada carbon dengan hydrogen. Itu maksud hydrocarbon. So in your hydrocarbon ada 85.7% carbon, 14.3% hydrogen. The molar mass is 56. Determine empirical formula and molecular formula. Okay, dia nak dua benda, empirical and molecular formula. So first thing we have to do, take a look at the percentage given. Dia dah cakap percentage by mass. So maksudnya kita boleh assume, mass of carbon is 85.7 gram, while mass of hydrogen is 14.3 gram. So masukkan dalam table 85.7 mass of hydrogen 14.3 gram. So macam tadi, find out the number of mole for each of the element. So here you should get 7.1417. This one you should get ni tak perlu yang ni tak perlu tekan kalkulator pun Mak malu je nanti tekan kalkulator, simple. Okay, next, the simplest ratio. Yang ni awak kena study betul-betul. Tengok betul-betul. Which mole is the lowest? So, ambil yang carbon lah. 7 obviously lagi kecil daripada 14. Okay, here you will get 1. Here you will get 2. Bukan roughly, you akan dapat memang exactly 2. So the empirical formula is CH2. Okay, masa sekolah dulu cikgu ajar macam ni ke? Okay, good. Okay, sama. Okay, good. So, kita baru settle satu part, which is find out empirical formula. Next, kita nak cari molecular formula. So, to find out molecular formula, you kena cari dulu N dia berapa. Okay, ingat balik formula tadi. Yang ni. To find out N, we are going to use molar mass of the compound divide dengan molar mass of empirical formula. So, dia dah bagi molar mass of a compound is 56 divide by molar mass of empirical formula is 12 times 2. So, you should get here 4. Okay, 4. Tak habis lagi. Sambung lagi. So, molecular formula of a compound CH2, everything here times by 4. So, kembangkan. So, the formula is C4H8. Sampai situ, faham?
Faham, madam.
Faham. Okey. Siapa tu? Yang ni simple lagi sebab lebih kurang apa yang awak belajar sebelum ni lah. Okay, last one. This one madam tak sure sama atau tidak dengan you belajar ke tidak zaman sekolah. Yang ketiga, we are going to find out empirical formula from the combustion data. Okay. So first, what is the combustion? Combustion of hydrocarbon, okay, will produce CO2 and water. Pembakaran akan menghasilkan carbon dioxide dan air. And in order for the combustion to occur, you need oxygen. Okay, so basically this is the equation. Okay, dalam soalan nanti dia akan bagi awak mass of carbon. So, dia akan bagi mass of carbon dioxide, dia akan bagi mass of water. So, kita akan cari mass of carbon daripada carbon dioxide and mass of hydrogen daripada air. So, how to do that? Let's have a look at the last example for today. Okay, kita baca satu-satu. 1 gram of sample of organic compound A was burned in excess oxygen. Maksudnya oksigen tu ada banyak. Combustion produce 2.52 gram of CO2 and 0.443 gram of water. Determine the empirical formula. Okay, dia nak empirical je. Okay, next. First step adalah calculate mass of carbon. So kita akan dapatkan mass of carbon daripada CO2 tadi. Sebab dalam CO2 ada carbon. So we know that one carbon is 12 grams. Divide by molar mass of CO2. CO2 molar mass dia 44. Okay, you darab dengan times 2.52 gram of CO2. Okay, Madam repeat. Nak dapatkan mass of carbon, okay, take 1 mass of carbon divide by total mass of CO2. Okay, darab dengan 2.52 gram of CO2. So you should get 0.6873 gram. So that is your mass of carbon. Dalam soalan, dia bagi 252. Means that out of 2.52, mass of your carbon is 0.6873 gram. Yang selebihnya adalah mass of oxygen. Okay, next we are going to find out mass of hydrogen. Okay, in water, okay, kita akan dapatkan mass of hydrogen daripada air. Tadi daripada CO2. Okay, we have 2 hydrogen in 18 in water. Okay, so mass of 2 hydrogen adalah 2 divide by 18. 18 is the total mass for water lah. So times mass of water given, which is 0.443. So you should get 0.0492 gram. So that is the mass of hydrogen. Okay, last one, mass of oxygen. Okay, we are going to find out mass of oxygen daripada mass of sample given. Awak tak boleh dapatkan mass of oxygen daripada CO2 and water. Walaupun ada oxygen, tapi jangan gunakan kaedah yang macam step 1 dengan step 2 untuk dapatkan mass of oxygen. Okay, so untuk mass of oxygen, apa yang kita akan buat? Mass of sample, dia ada bagi 1 gram minus 0.6873 minus 0.0492 gram. Okay, ini mass of sample, kita akan tolak dengan mass of CO2 minus mass of CO2 pula. Mass of carbon tolak mass of hydrogen. So you should get here 0.2635 gram. So this is the mass for oxygen. Okay, so Madam explain balik. This is our sample. And in example 13, the sample given is 1 gram. Combustion of sample in excess oxygen produce CO2 and water. Okay, mass of CO2 dia ada bagi, mass of water pun dia bagi. But to find out mass means that our sample mass of compound A, sorry ya. Yang Madam bagi kat atas tadi, if your sample is hydrocarbon. Untuk example 13, dia tak cakap sample awak hydrocarbon atau tidak. Dia just mention sample awak adalah compound A. So, for this one, if we look at the table, ada oxygen. Means that the sample also contains oxygen. So you have to find out X, X, Y, Z lah. Okay. So kita akan dapatkan mass of carbon. Kita akan dapatkan mass of carbon from CO2. Okay. We are going to find out mass of hydrogen from water. Cuma kat sini kena hati-hati. To find out mass of oxygen, kita akan tolak mass of sample minus mass of carbon and mass of hydrogen. Do not use mass of CO2 and water to find out mass of oxygen. Please don't do that. Okay, kita dah dapat tiga-tiga mass. Let's move on to the table. Okay, fill in the table. Okay. Fill in the table. Okay, find out mole.
Madam.
Ya, Husna.
Yang hydrogen saya 0.04.
Yang hydrogen 0.
Madam salah tulis dekat dalam table.
0.04. Okay. Okay, thank you. Okay, so okay, I left you here lah. Please do this. Yang Madam akan bagi jawapan during our next class lah. Okay, so as for your homework, this one kita akan discuss masa hari Selasa nanti. Please do all these 5 question. Lepas tu scan siap-siap. Okay, Madam akan minta awak bentang. Okay, bukanlah bentang. I mean share the answer macam yang tadi kita buat. Okay, one more thing. Tolong guna pen. Sebab kalau pensel tak jelas. Okay. We will stop here. Ada soalan nak tanya? Okay, kalau tak ada, Madam akan stop sini. So basically, hari ni kita apa yang kita buat adalah kita tengok balik average atomic mass, okay, formula kimiki. After that, kita ada tengok mole concept. Okay, macam mana nak cari number of particles. Okay, next kita akan tengok mole tu sebenarnya bukan taik lalat, tapi mole adalah unit untuk atoms, molecule or ion ataupun anything. Okay, next kita ada tengok molar mass. Then kita tengok empirical and molecular formula. So Madam pergi laju sikit because Madam tahu awak dah belajar yang ni. Okay, so Yang ni kita lebih kepada recap lah. Okay. So next week, Madam akan discuss yang ni. Okay. Concentration of solution. Ada 5 jenis concentration. So kita akan tengok satu demi satu. So that is for the next week lah. Okay. So I think that's all for today. Thank you. Thank you all. Sorry ya, hari ni start lambat sikit, ada masalah teknikal. So kalau tak ada apa-apa, kita sudahi dengan tasbih kifarah and surah Al-As. Okay, terima kasih.
Thank you, madam.
Okay, bye. Welcome.
Thank you.
Oh, by the way, jangan lupa, guys, jangan lupa isi attendance. Madam dah bagi link dekat Google Classroom ah. Welcome, Ci.
Thank you, madam.
Welcome.
Thank you, madam.
Welcome.
Thank you, madam.
Welcome.